So this is my setup. I've got 3 rows of 6 panels, so 18 panel total. They're SolarWorld 290 watt solar panels, and I wanted to basically douse them with cool water and see how much extra power they can put out. Kind of a test to see if it's worth actually sprinkling the panels without building this elaborate system, kind of a pre-test. So if you can see the video, I've got about 125-ish degrees on the panels. They're sitting out in the sun. It's about 90, 95 degrees out. They heat up. I've seen them go up all the way up to 135. These have been very high performing panels. I put them on stands so I can get some extra use out of them in the summer before I put them on my roof. So here you can see they're pretty hot, 120 degrees. As panels heat up, their efficiency goes down, so they'll produce less power. And so the theory is if you cool them off, they'll generate more power. So I'm going to kind of prove that concept works by the experiment I'll be doing. So this is behind my solar system setup. I got some wooden stands with some unistruts on there, and the solar panels are mounted to those. Down here is a microcontroller unit. It's got 2 thermocouples. One measures the air temperature, and then one measures the panel temperature, and then depending on the difference between the two, there's a relay that actuates and turns on the solar panel sprinkler, which is basically a lawn and garden sprinkler. And then I also got an LCD that kind of spits out what the temperature is and what the status of the system is. So here I'm trying to obviously plug it in. It's kind of hard to film and plug in. And I got my thermal camera on, cover up my microcontroller unit so it doesn't get wet when the sprinkler comes on. It's kind of a jury-rigged just to see if it works. And so this will be the front side of the panels, and you can see they're probably 124 some odd degrees, 128, and right when the sprinkler turns on, you can really see that it's seriously knocking down the heat, probably a good 20 to 30 degrees. There it's 135. So if you wait a little bit, you'll see the sprinklers turn on right about nowish. And so now you can see the blue obviously is the sprinklers turning on, and it's really starting to cool down that panel. And so for my results, depending on how hot the day was, where I live, it can get up to 95, 100 degrees in the summer. This can actually increase the production output of the panel by 9 to 12%. Again, depending on a lot of things, the amount of sunlight shining, the temperature, the angle of the panel. There's a lot that comes into play with the increasing the efficiency, but knocking down the heat is the biggest thing in the summer. And so if you can add 10 extra percent to your system, depending on how many panels you have. In this case I had 3 rows of 6. I'll kind of show you the other rows later on. It added a significant amount of production onto the panel. So once I get these on the roof and make them fully mounted, then I'll kind of take this system and put it on my roof and kind of sprinkle the panels using rainwater or some kind of free water mechanism. So this is a shot from the other set of panels I got in the back. There's the second row of 6, and here you can see they're 124 degrees. I got a little owl there in the left corner, and the idea was to keep the birds from crapping on the panels because that covers up cells and drops the efficiency. But after a while the birds, I guess, became smart enough and I think crapped on the owl. But anyway, so that's the difference between the two. And obviously the water doesn't quite cover the entire panel, but it does fairly decent. This is the curve of one of my panels. If you notice the last spike at roughly about 12:30, and then it pops up there, that's when the water's turning on, and so that's the roughly 12% increase. Okay, here's a graph of one of my panels. You can see here roughly about 9 o'clock is when the sun clears my fence, and pretty much the panels turn on hard. Here I guess we had some rain at about 2 o'clock, but on average the panel will produce probably about 220 watts in the peak of summer. So the next part I'll show my calculations. If I'm doing 220, I'm going to eke out another 12%. That should give me roughly about 26 something watts. And then if I multiply that through all the panels that I have, the 18 that are sitting on stands, I kind of come up with a calculation. I'll show you that next. Okay, this is my calculation section. I'm showing that If my panels are 220 watts at 12%, I can get another 26.4 watts at 18 panels. That's about 475.2 watts. If I run them at 9 hours a day, that's 4.27 roughly kilowatt hours. At 4.27 kilowatt hours at 30 days, I'll get 128 kilowatt hours. At 12 cents, which is what we're billed here, that's $15 roughly. And over a 6-month time period, you get about a savings of $92. And if you fast forward to 10 years, roughly $920. And this will vary depending on obviously the weather, and there's a lot of other circumstances and variables involved, your utility rates, all that good stuff. But you can definitely see it after a long term, it'll actually put a dent in your bills. So this gives you the freedom of not having to pay the utility man and putting that extra money in your pocket or your wallet or however you store your money under your bed and spend it on whatever you want.
Let's look at the circuit. Again, this is an old PIC Kit 2 16F690. Probably still make it, but they have newer chips that probably do a whole lot more and run a whole lot faster. But again, this is what I had laying around, so I use that. This is a microchip temp sensor I'm using, a relay, thermocouples there, and an old motor driver I had that basically takes in, I think, 12 volts and spits out 5 to control all the digital stuff. And then my power supplies, one that runs the valve, and one that supplies the power to here, so it powers the whole circuit here. So the 12 volt powers, I believe, this relay. It's been a while since I had this out, so it's kind of messy and there's jumpers everywhere, but obviously you can see that it did work.
I'll put a link in the description below so you can buy all these parts and build this for yourself. Microchip temp sensor, motor driver power supply, 12 volt relay, thermocouple, Rainbird valve, misting nozzle, thermocouple voltage converter, 8-bit LCD display, and the PIC Kit 2. Alright, so that's the end of the project. Please like and subscribe, and hopefully this helps someone and piques some interest on increasing the solar panel efficiencies.